All right, folks, last little bit here. Parts of similar triangles. So remember after the new year when I made you that terrible focus note taking with the centroid? No, ortho center. Remember it was like very difficult and I did a bad job? We talked about those special segments like a median, angle bisector, and an altitude. So we're using those special segments, but now they're in similar triangles. And it's basically the same thing over and over. We're just going to rinse and repeat because they all have proportional relationships with corresponding sides, okay? So it's going to feel very redundant, but hopefully it's an easy way to end this chapter. Okay, so the first one up is an altitude. Remember that altitude is a segment that goes from a corner of your triangle and makes a right angle with the opposite side. So if you have two similar triangles, the altitudes are proportional to corresponding sides. So if you match up your altitudes and set it equal to two sides that match, you're able to solve for missing variables, lengths, or whatever. And again, there's many ways to write that proportion. That's just the way I chose. But just keep your order the same and you'll be okay. All right, our next one are our angle bisectors. So if we have two similar triangles like QRS and KLM, our angle bisectors are proportional to two sides that we match up. Here you go, dude. Thanks for coming.
Is this for all the notes?
Yep. Just a review. Okay. Thanks for coming. All right, folks, last one here is our medians. Same thing. If we have two similar triangles, then their medians are proportional to two matching side lengths. How do you know that's a median?
I'm not really sure.
Yes, because it's splitting an opposite side into two equal parts. Perfect. Goes to the middle. All right, let's try one. Let's first list out what kind of a segment is this? Which special segment? Angle bisector. Maybe we should write that down. That's good practice. It's an angle bisector. I like to start with my variable, just a good starting point. So if I say x, what does x match? 8. Now what does the other side have to look like? 15 over 12. Yep.
Wow.
Now we have a very kindness.
Yeah, don't be mean.
That just came out.
120.
120.
Yeah.
Oh, is that
What?
Are you guys okay with 10? All right, what kind of a segment do we have on the second one?
the first one?
Altitude, it's making a right angle. It's how tall our triangles are. What's our proportion gonna look like? Very good.
Wait, why does it matter if it's like an altitude or a...
It doesn't. I just think it's good for us to remind ourselves what they are.
Okay.
But you're right. It doesn't make a difference at all.
Which means that approximately that 5 by 20 is like...
What is it?
Well, because there's 8 times 10 is uniforms. It would be 24. Then you divide that by 2 times 20.
All right, last one. What kind of a segment do we have? Median. What's our proportion going to look like? X over 3 equals 13.5 over 9. Good. Go for it. I'll catch up to you.
It's actually pretty good. Yeah, I said it. About 8.4. Why? Yeah, you did.
4.5.
It's actually 4.5.
4.5.
Probably because of the whole opposite line. Yeah, that was
Wow.
because I switched my
You
5.
still can't put pressure on it.
Yes,
No,
it's
put it down and try to
wonderful.
Well, the only thing I don't like is I got so much long face now. It looks
I'm gonna tell the friend.
okay, now I gotta fix it over there.
Why'd you just throw a gum
Yeah, Julia, don't do that.
Yeah, you should probably read it.
I still like if I forget my calculator. Does it look the same as what I want? Because I always gotta do this because it like falls down.
I don't like it.
Was that?
So what if
So that was over 3 minutes of waiting. I understand this lesson is very redundant and it's the same. And you guys choose where you sit, but if it's going to be like that, you will not choose where you sit. Not everyone in here likes to have a social hour. There are some people in here that just want to get their work done. And that was all very selfish. Okay? Work time's your time. I think notes should be our time, right? Don't be rude. Just get through the notes. Okay. Last little thing here on this chapter. Notice that this is just one triangle. We don't have 2 different triangles, even though it appears to be 2. But if you have an angled bisector in a triangle, then it splits the opposite side into segments that are proportional to corresponding sides. So those 2 little pieces, like KM and ML, are proportional to the 2 full sides that are left. It's going to feel pretty similar to what you're just doing, but it's in one triangle instead of 2. All right, so again, we're just matching, folks. So what do you guys want to start with?
you should do? Wait, could you do 18 minus x over 14?
Sure.
That
So-
works.
Do we agree that that's 18 minus x? The whole thing's 18, right? Okay, so let's write that down. We need to use that anyways. But yeah, we could do 18 minus x over 14. Okay, now what matches 18 minus x? X over 6. Yep. There are many ways to write your proportion as long as you go the same order. Don't forget to distribute the 6 to the 18 and the negative x. What is that one?
18 times 6. What is it? 106.
Can I get a decimal? That's okay. Someone tell me what you get.
5.4.
Perfect. All right, the next one's pretty straightforward. What do you guys want to write? X over 13 equals 4 over 6. Perfect. Yeah, we'll get decimal somewhere between 8 and 9.
8.67.
8.6 repeating.
Yeah.
8 2/3. Perfect. You guys get a head start on the last one. I'll catch up to you, okay?
I think you might.
Did I?
I got 8.
11.
You got 11.2?
I got 11. Wait,
You
you
know
know how I did
11.2?
I did 29 x over x. And 11 over 14.
Because you put it in. Oh, I messed up the numbers. Why is it not erased?
Oh, 35.
No.
That's okay.
I was so confident in that answer.
A lot of room for errors in this, you know?
Yeah, but I was just.
Yeah,
Brandon's sticking everybody's paper.
The stack I gave.
Oh my.
Yeah, we're guessing.
Okay, now we can see what we're
Oh.
Yeah.